I'm Jiahao. I'm going to introduce our work, depth consistent human modeling for multiview detection. Multiview pedestrian detection aims to localize pedestrians on the BV plane, but it is challenging in crowded scenes with sparse camera views and heavy occlusion. Existing methods fall into two categories: label-based methods, which offers accurate localization but require costly annotations, but label-free, which lack annotation but perform poorly. We propose label-free methods that matches label-based techniques and set a new state of art in label-free pedestrian localization. Fusing multiview information using monocular depth estimation is a straightforward method, while monocular depth estimation struggles with multiview consistency, leading to noisy 3D reconstructions. We introduce a depth-consistent modeling approach that fuse views into an accurate global point cloud for reliable pedestrian detection. After fusing views into accurate point cloud, we model humans as segmented Gaussian primitives, enable robust multiview fusion and detection in crowded and occluded scenes. Generating consistent pseudo-depth labels in occluded scenes for mono-depth fine-tuning is challenging due to limited overlapping. To solve this, we propose a superpixel-based initialization method for GIS optimization, enabling reliable depth labels in overlapping regions. After GIS optimization, we applied pseudo-depth filtering to retain the valid labels for mono-depth fine-tuning. During pseudo-depth label generation, we find that occlusion can cause misdetections, which may impact the performance of our method. To mitigate this, we introduce a compensation mechanism during optimization to recover misdetection. The pseudo-depth generation using GIS, mono-depth fine-tuning, and multiview detection compensation form an iterated loop. The Gaussian optimization generates pseudo-depth labels to guide the mono-depth estimation, and the fine-tuned network updates the depth prediction serve as the next initialization for GIS optimization. Additionally, the refined depth improves detection, enhancing the GIS optimization. As shown in the figure, the expanding green regions highlight the iterative refinement, where each cycle adds valid depth estimation to improve the subsequent round. In inference, the proposed pipeline consists of two main steps: human modeling, reconstruction, and localization. Firstly, we use optimized mono-depth estimator to project depth onto global point cloud, convert it to Gaussian, where the pixel RGB define color, point position set the means, and the camera parameters determine the rotation and scale. In the localization, we propose multiview pedestrian matching to map cross-view pedestrian by Gaussian, which is subsequently clustered for pedestrian localization. We evaluate our methods on wide thread, terrace, and multiview X datasets, and achieve the best and competitive performance compared with label-free methods. As shown in the video, we achieve more complete and accurate 3D reconstruction than baseline in occluded and sparse view setting. Also, the pedestrian can be clustered as segmented Gaussians without any cost multiview Multiview label. More results and the source code are available on our project page. Thanks for your watching.